Hi sir, I am Nicholas Cabanillo from BSIP to Senior Development, and this is my video presentation in your subject, sir. Memory management is the process of controlling and coordinating computer memory, assigning portions called blocks to various running programs to optimize overall system performance. When a program no longer needs the data in previously allocated memory blocks, those blocks become available for reassignment. Memory management is the functionality of an operating system which handles or manages primary memory and moves processes back and forth between main memory and disk running execution. Memory management keeps track of each and every memory location, regardless of either it is allocated to some process or it is free. Classify memory requirements for a computer system. Memory is the most essential element of a computing system because without it, computer can perform simple tasks. Computer memory is two basic types: primary memory, RAM and ROM, and secondary memory, hard drives, CD, and etc. Random access memory or RAM is primary volatile memory, and read-only memory ROM is primary non-volatile memory. These are the types of memory. RAM is for SRAM and DRAM, and the ROM is PRAM, EPRAM, and EFRAM. Random access memory, RAM. It is also called read-write memory or the main memory or the primary memory. The program and the data that the CPU requires during the execution of a program are stored in this memory. It is a volatile memory as the data is lost when the power is turned off. RAM is further classified into two types. SRAM is static random access memory and DRAM, dynamic random access memory. These are the difference between SRAM and DRAM. DRAM number 1. Constructed of tiny capacitors that leak electricity, and the SRAM is constructed of circuits similar to D flip-flops. DRAM number 2 requires a recharge every few milliseconds to maintain its data, and the SRAM is hold its contents as long as power is available. And the DRAM number 2 inexpensive, and the SRAM is expensive. Number 4 and DRAM slower than SRAM, and the SRAM is faster than DRAM. DRAM number 5 can store many bits per keeps, and the SRAM cannot store many bits per keeps. Number 6 in DRAM uses less power, and the SRAM uses more power. Number 7 in DRAM generates less heat, and the SRAM generates more heat. Number 8 in DRAM used for a main memory, and the SRAM used for cache. Difference: read-only memory ROM stores crucial information essential to operate the system, like the program essential to boot the computer. It is not volatile. Always retains its data. Used in embedded systems or where the programming needs no change. Used in calculators and peripheral devices. ROM is further classified into 4 types: MRAM, PRAM, EPRAM, and EFRAM. Types of read-only memory ROM. PRAM, programmable read-only memory. It can be programmed by the user. Once programmed, the data and instruction in it cannot be changed. EPRAM, erasable programmable read-only memory. It can be reprogrammed to erase data from it, expose it to ultraviolet light. To reprogram it, erase all the previous data. EFRAM, electrically erasable programmable read-only memory. The data can be erased by applying an electric field with no need for ultraviolet light. We can erase only portions of the chip. MRAM, mass ROM. Mass ROM is a kind of read-only memory. It is mass off at the time of production, like other types of RAM, and mass RAM cannot enable the user to change the data stored in it. If it can, the process will be difficult or slow. These are the difference between RAM and ROM. Number 1 in RAM, temporary storage, and the ROM is permanent storage. Number 2 in RAM, store data in MBS, and the ROM is store data in GBS. Number 3 in RAM, volatile, and the ROM is non-volatile. Number 4 in RAM, used in normal operation, and the ROM is used for startup process of computer. And the 5 in RAM, writing is faster, and the ROM is writing data is slower. Role of memory in computer system and operating system. Memory is the electronic holding place for the instructions and data a computer needs to reach quickly. It's where information is stored for immediate use. Memory is one of the basic functions of a computer, because without it, a computer would not be able to function properly. Memory is also used by a computer's operating system, hardware and software. There are technically two types of computer memory, primary and secondary. The term memory is used as a synonym for primary memory or as an abbreviation for a specific type of primary memory called random access memory RAM. This type of memory is located on microchips that are physically close to a computer's microprocessor. If a computer's central processor CPU had to only use a secondary storage device, computers would become much slower. In general, the more primary memory a computing device has, the less frequently the computer must access instructions and data from slower secondary. From my storage, people in the computer industry commonly use the term memory. To prefer the RAM, random access memory, a computer uses RAM to hold temporary instructions and data needed to complete tasks. This enables the computer CPU's central processing unit to access instructions and the data in the memory very quickly. A good example of this is when the CPU loads an application program such as word processing or page layout program into memory, thereby allowing the application program to work as quickly and efficient as possible. In practical terms, having the program loaded into memory means you can get work done more quickly with less time spent waiting for the computer performance. And this is the example. Hard drive, RAM, CPU, hard drive. The process begins when you enter a command from your keyboard. The CPU interprets the commands and instructs the hard drive to load the command or program into memory. Once the data is loaded into memory, the CPU is able to access it much more quickly than if it had to retrieve it from the hard drive. This process of putting things the CPU needs in a place where it get at them more quickly is similar to placing various electronic files and documents you're using on the computer into a single file, folder, or directory. By doing so, you keep all the files you need handy and avoid searching in general places every time you need them. The term memory can be defined as a collection of data in a specific format. It is used to make sure instruction and process data. The memory comprises a large array or group of words or bytes, each with its own location. The primary motive of a computer system is to execute programs. These programs, along with the information they access, should be in the main memory during execution. The CPU fetches instructions from memory according to the value of the program counter. To achieve a degree multiprogramming and proper utilization of memory management is important. Many memory management methods exist, reflecting various approaches, and the effectiveness of each algorithm depends on the situation. In a multiprogramming computer, the operating system resides in a part of memory that the rest is used by multiple processes. The task of subdividing the memory among the different processes is called memory management. Memory management is a method in the operating system to manage operation between main memory and disk during the process execution. The main aim of memory management is to achieve efficient utilization of memory. It is the most important function of an operating system that manages primary memory. It helps processes to move back and forward between the main memory and execution disk. It helps us to keep track in every memory location, irrespective of whether it is allocated to some process or it remains free. An operating system is a specialized collection of software that stands between a computer hardware architecture and its application. It performs a number of fundamental activities such as file system management, process scheduling, memory allocation, network interfacing, and resource sharing among the computer's users. Operating systems have evolved in the complexity over time, beginning with the earliest computer in the 1960s. With early computers, the users typed programs into punch, tape, or cards, which were read into computer, assembled or compiled, and run. The result were transmitted to a printer or a magnetic tape. This early operating system engaged in batch processing, etc., handling sequences of jobs that are compiled and executed one at a time, without intervention by the user. Accompanying each job in a batch were instructions to the operating system, detailing the resources needed by the job, such as the amount of CPU time required, the files needed, and the storage device in which the files reside. From this beginning came the key concept of an operating system as a resource allocator. This role became more important with the rise of multiprogramming, in which several jobs reside in the computer simultaneously and share resources. For example, by being allocated fixed amounts of CPU time in turn. More sophisticated hardware allowed one job to be reading data while another worked to a printer, and still another performed computation. The operating system thus managed these tasks in such a way that all the jobs were completed without interfering with one another. The advent of time sharing, in which users enter commands and receive results directly at a terminal, added more tasks to the operating system. Processes known as terminal handlers were needed, along with mechanisms such as interrupts to get the attention of the operating system to handle urgent tasks, and buffers for temporary storage of data during input-output to make the transfer run more smoothly. Modern large computers interact with hundreds of users simultaneously, giving each one of the perception of being of sole user. Another area of operating system research is the design virtual memory. Virtual memory is a sim that gives users the illusion of working with a large block and contiguous memory space, perhaps even larger than real memory, when it actually most of their work is actually storage disk. Fixed size blocks, pages, or variable blocks segments of the jobs are read into main memory as needed. Questions such as how much memory space to allocate the users and which page segments should be returned to this swap out. To make room for incoming page of segment must be addressed in order for the system to execute job efficiently. The first commercially viable operating systems were developed by IBM in the 1960s and were called OS 360 and DOS 360. Unix was developed at Bell Laboratories in the early 1970s, and CIS has spawned many variants including Linux, Berkeley Unix, and GNU, and Apple's iOS. Operating systems developed for the first personal computers in the 1990s include IBM's and later Microsoft DOS, which evolved into various flavors of Windows. An important 21st century developed in operating system was the key becoming increasing machine independent. This is the references. And that's the end of my video, sir. Thank you.